So thank you so much. And with that, I'd like to introduce my colleague, ML Vitas, who's just going to talk a little bit about how Energy Trust participated with the program.
Great. Thanks, Ellen. I am ML Vitas. I work with Energy Trust of Oregon, and I see a lot of familiar names and a few familiar faces. So thank you for showing up this afternoon. This is really great. I live in Bend, and where I'm located, I have a window, and I was like, oh, maybe the sun will have moved so that it's not, it may be blinding me partway through, but we're thrilled to be focusing on this project today, which is also based in Bend. It was partly supported through some incentives with Energy Trust of Oregon. And for those of you that don't know, Energy Trust of Oregon is an independent nonprofit, and we are here to help with energy efficiency. And there's lots of different programs under the umbrella of Energy Trust of Oregon. We have new buildings and existing buildings. That's on the commercial side. We have residential, both new and existing. There's industrial, ag, there's solar. So basically, you're using energy, you should be talking to someone with Energy Trust of Oregon. I work with Ellen as well. We work together with the new buildings program. So that's new commercial construction. Think of a building coming up out of the ground, new construction or an addition or a major renovation. We want to talk to you about the possibility of Energy Trust incentives and helping you be more energy efficient. And we do that through design assistance, installation incentives, and in a few cases, some post-occupancy incentives. We have a specific offering called Market Solutions for multifamily projects. And the project that we're going to be talking about in a few more minutes in more detail is a multifamily project. And it did go through our Market Solutions offering. And you all, as people in the design and construction world, you know code changes. So we, with our incentives, we move them along. They're always going to be like right there. As code is getting more and more stringent, our incentives are going to be also getting more stringent. So the specific incentives that this project received, they're not the same today. So if we start to talk about in a lot of detail about what they did on the project, it may be different for your project today. Essentially, though, with our Market Solutions offering with multifamily, we like to be in that in-between space between prescriptive measures that it's efficient, you install it, we have an incentive for it, and then the other end of the spectrum being whole building energy modeling projects, where they're going to look at all of the different inputs that could make a building be more energy efficient. With our Market Solutions multifamily offering, our team of engineers do an internal model of that project, energy model, and you as the representative for the project, you provide those inputs. It can be envelope efficiency, better windows, it can be the heating and cooling system for a project, the water heating, low flow fixtures, Energy Star appliances, all of those inputs we will take, and then we run the model and come up with your project being good, better, or best for the incentives. And I really want to turn it back over to LRS to talk specifically about the project. I'll be on the call in the background if there's questions around Energy Trust incentives, but I want you all to hear about the project specifically. So I'll do the handoff now. Thank you.
All right, thanks all. My name is Matthew Dreska. I am an architect at LRS Architects. LRS Architects has been around for over 40 years. We've done stuff from affordable housing, mixed use, senior housing, civic, workplace, the list goes on. A little bit about myself. I grew up in Bend. I'm currently living in Bend again, but I cut my teeth on the architecture profession in Portland for a little over a decade. So when LRS opened our office here in 2021, I was very excited about the chance to help Bend grow thoughtfully. So I also jumped at the chance to present, even though I did not personally work on this project. So when I say we, that means every other person other than myself on this project. So let's just jump in here. So right now we've got Canal Commons, this is a view facing north. This is a affordable housing project, in total 96 units. So we'll jump into the achievements pertaining to the team itself. So I believe I saw Rob Roy is on the call, but we are very fortunate to work with a developer that is always asking how they can make the project better. This includes a lot of sustainable features that they are very interested in and have done on many other projects, right? So lower energy consumption, protects against rising utility cost, and rent to keep it lower for longer, right? So for this project specifically, affordable housing project, the income restricted to residents earning less than 60% AMI, the average mean income of the area. So at the time in 2021, in Bend, it was $74,000 for a family of 4. And for the phases, this ended up being in 2 phases. So for phase 1, it took 20 months of construction due to COVID and other delayed materials and supplies. And then phase 2 took 21 months due to COVID as well. During this time of design and construction, the team was able to evaluate design decisions with life cycle cost analysis, which is really fun to do. So the project team, like I said, Pacific Crest is the developer that is Rob Roy, LRS ourselves, and Sunwest Builders, including Ashley Vance for both structural and civil. Again, these are all local firms, which we're very happy to work with. And some of these team members have worked on affordable housing projects for the past 20 years, right? So Colbright, Bend Electric, CEA, Winter Creek Restoration / Land Effects, and E2 Solar. It was a really great team. But jumping into the project information, like I said, phases. So for phase 1, it started in 2019, completed in 2021. The construction cost was $10.8 million, which equated to about $194 per square foot. Then also equates to $225,000 per unit. Now, going to the change orders, we actually had negative change orders. Again, this goes to the cost analysis and the dedicated team. So the first phase actually also included the community building. You'll see a site plan later. For phase 2, this started in 2021, right after the first phase completed, and then that was completed in 2023. You can see the construction cost was a little bit more per square foot, and a little bit more per unit. You do also see that the change orders actually was a higher negative amount. So this had to do with lessons learned, right, from the first phase, and which was great from Sunwest because they were on board from the very beginning. So we can't talk about affordable housing without talking about funding and all the different sources, right? So it needs to come from multiple sources. You can see the list here, including low-income housing tax credits, Oregon Housing and Community Services. So the land was actually acquired through the city of Bend. This was surplus property, and this was a great opportunity. And also the city of Bend is very proactive in creating incentives for affordable housing. So like I just said, selling of surplus property. They also provide low and no interest loans, property tax exemptions, SDC charge exemptions, so that's system development charges, expedited planning and permit review, and increased density of up to 100% for affordable housing, and also an increase in height. So you'll see at the bottom there, so you have City of Bend, the SDC exemptions, and the Bend Parks and Recs SDC exemptions. So these would have been the SDCs charged, but they were not. So essentially, for phase 1 and 2, the project saved about a little over $1 million. The Bend Park and Rec SDC exemption was not part of phase 1. I think because of certain funding and whatnot. Again, I say we. I was not involved in the project, but that's my understanding. And of course, there's private investors that help out on these projects too. So I touched on sustainability previously, and the developer being very motivated by this, as well as LRFs. So this is a tool that we used to get to the Path to Net Zero, an ETO program. So it measures your energy use intensity, your EUI. So for a typical multifamily building, the EUI is at 52. Oregon code gets you to 41. And then the project's goal was to get to 13. You can see in the upper right-hand side, there is a graph over there. So the baseline is at 54 EUI. It's pretty small, but the target is to get to 11 EUI. So if you're within that 11 EUI, you're at net zero. I believe the project was right on the precipice of that, or might have met it. And I can ask Jim or Rob at some other point. So more about sustainability. So the Oregon Housing and Community Services, OHCS, requires new construction to meet one of the sustainable design requirements, which is LEED, Green Globes, or Earth Advantage, EA. Pacific Crest selected EA on one of its first projects and continues to use EA. So for this project, of course, we went with Earth Advantage and Earth Advantage Platinum with that. So for the phase 1, it reached 123 points, which you can see for Platinum, we met that, right? 120 is the threshold. And then for the second phase, it reached 140. That has to do with the cost analysis and lessons learned from between phase 1 and phase 2. So kind of the big design moves, challenges within this list would be building orientation, east-west, something you learn in architecture school. Myself, I learned at U of O, as well as I would say the advanced framing techniques. When you want to make a more sustainable building or energy friendly, the exterior envelope is where you need to go. And I'd also point to the central hot water system. So essentially, this project wanted to hit on all the low-hanging fruit items, the checklist items in the Earth Advantage checklist. So here's a site plan. So this is a 5.2 acre site adjacent to a 127 acre park. This is the Pine Nursery Park. It's in Northeast Bend. It's a great spot, beautiful views, dog parks, pickleball, you name it. So this is a very activated area and a great place for people to live. So you can see in the upper portion of the site, there's the 36 unit building. And then towards the southeast, you have the other 24 unit buildings that abut each other. And then the Commons building, which is in the south portion. And then there's one more building to the very south, which has 12 units. What's great about the site, and I'll say about the developer, is we have placed areas for the residents to grow food and raise bed gardens, and that give them different options of living more sustainably, not just through energy savings and lack of consumption. But we'll start getting a little more technical. We'll get into the building envelope, like I had mentioned before. So for advanced framing techniques, we chose to do a double stud wall using 2x4s with a 8-inch plate. This allowed us to put in 2 layers of R15 batt insulation. So the team evaluated the cost of single stud, double stud, exterior continuous insulation, ICF walls during the design phase. And the double stud construction, as you see here, came as the most cost effective. Even though the wood prices did escalate during the pandemic, it did not get reevaluated for the wall options because it ended up working out very well. More envelopes. So the windows, you can see here we have a casement window. So in lieu of sliders, casements are better at reducing infiltration. And also these are double pane, low E, kind of the sort of standard stuff that you do. Again, this is low-hanging fruit that we feel that every project should be incorporating. Just a little aside right there. But also you have to do a blower door test. So for us, we ended up hitting 2.46 air changes per minute at 50 pascals. Again, this is more technical stuff. If people want to nerd out, they can. I don't know if I'm going to on this one. But I will just say that some of the weak points that will happen in your blower door test are exhaust fans, windows, doors, and ERV venting, which we will hit on later. But these are the things that we focused on in this project. And one of the big things is thermal breaks, right? The thermal breaks around the windows are very crucial to mitigate heat loss as well. Now we'll get to the roof, the 5th elevation. So this is a gable roof, and it was designed to provide shade during the summer, as well as keep water away from the building. So in a typical roof truss heel, you have about 16 inches. These are 30-inch heels, sometimes called an energy heel, which allows for a lot more blown-in insulation. So we ended up using uncompressed R80, and it was looked at between R60 and R80, and modeling showed better results for the R80 insulation. Better R value, better efficiency. So more about the roof. This pertains to the attic and insulation and ventilation. So I know Jim and Rob have done multiple cold roofs. So that is basically defined as meeting 3 times the amount of attic ventilation required by code. So let's say it's, 25, 30 degrees out right now, and you go up into your attic space into this cold roof, it's going to be that same temp. This mitigates, essentially eliminates ice damming as well as keeping the roof form very simple. So per this graphic, you can see where there's eave roof venting, as well as gable and attic roof vents. These are the cupolas right in the middle of the green portions. And this building was divided up into 8 different attic areas relative to where the demising walls are located and per NFPA 13R requirements. So here you see the cupolas on that bottom right image, which have very large louvers, and the large louver on the gable end as well. So there is a lot of airflow through here. Again, these are called cold roofs. So you can see the calculation per OSSC 1203.2 at that 150 square feet. So you would only need 14.1 square feet of louver. However, if you go to the very bottom with the cupolas, we are able to get 60 square feet of venting. That has a lot more venting that is required. Okay, we'll get into the MEP portion. So we'll start with mechanical, the systems used here. So all the buildings use VRF, variable refrigerant flow units. These are your mini splits, right? You've got a head unit in your unit, and then you've got a fan on the exterior. So what's interesting about this project is all the red dots in the site plan are where there are locations of the fans that supply the heads to the units within the individual buildings. So there are 4 shared heat pumps per 12 units to maximize the heat pump efficiencies to heat and cool the units. So what's really great about this system is, for instance, if units on the south-facing elevation may need cooling, units on the north actually can get heated. How do I know how that works exactly? Nope, but it actually works great. We'll keep moving on. Talking about VRFs again, this shows one of the enclosures that has the fans in it, with a really nice view of the mountains in the back. That looks like maybe middle and north sister right there. But the reason that these were actually enclosed is due to the amount of snow and ice that happened in Bend. It hasn't been happening till the last week, but it's probably a really good thing that these are actually enclosed, because it would reduce the efficiency of your fans if they were covered with snow. We'll hop into another great mechanical system. So the ERVs, so energy recovery ventilation. So each unit in the building is individually controlled for heating and cooling. All right. So what these are able to do is recover 90% of the heat for recirculation throughout the building. So this is the 36 unit building right here. And it's just a really great system. These are all actually located within the attic. And it provides more efficiency and energy efficiency as well. I am not a mechanical engineer, but just know that these systems are awesome. Also, so the developer, Rob Roy, is currently working on upgrading the filters, maybe already has, on the ERV because of the pandemic and issues of airborne virus, right? So you're using the recirculated air. You really want really good filters on that. So this is just a blown up portion of the ERV, the ducting off of it, and all the other good stuff there. So like I had said, I'm not a mechanical engineer, but we do have a great YouTube link at the bottom here, which I believe all these presentations are shared on the ETL website. Don't quote me. So we'll hop into the E of MEP, electrical. So this project employed both solar PV and solar thermal. What you're seeing here in the orange is the solar photovoltaics in the south portion of this 36 unit building. And then on the west side, on the little small gable end there, is the solar thermal. So this is a 304 kilowatt solar PV array, and combined the solar PV and the solar thermal generate 550,000 kilowatts per year. So that's offsets 50% of the entire project load. That is a big deal, especially for affordable housing and keeping everybody happy, cooled, heated, and not charging a lot of money. The roof slope of this is 512, and so at our latitude and azimuth, it actually works out really well to get a lot of efficiency out of the PV array. And so harking back to the cold roof, because PV arrays don't necessarily work well when they're superheated, especially with that heat coming through your roof, because these are cold roofs, it actually lets the PV array be more efficient because it will not overheat. So moving more into electrical, we've got the appliances. So they're all Energy Star. Great ETO program there. So the savings just for refrigerators and dishwashers is 26,000 kilowatts per year. These are all big numbers and they're all real. And this is all really good stuff. So per usual, 100% of the lighting is LED. That I think that's pretty much a standard across the board for affordable as well as market rate housing. And they are all controlled with vacancy and occupancy sensors and or ambient light. So again, this saves 102,000 kilowatts per year for indoor lighting and 32,500 kilowatts per year for outdoor lighting. That's the comparison to incandescent, which I'm not sure what project would use that. And then electric cadet heaters were used in bathrooms that were located on exterior walls to add extra heating there in case, because it gets cold. So we'll get into the P of MEP, plumbing. So in this photo here on the left are the hot water tanks, and on the right are the solar thermal tanks. So they work together. So the solar thermal system, including the 16 solar panels of the roof and over 1,000 gallons of hot water storage, save 77,000 kilowatts per year and provides 65 to 70% of all the hot water needs of the building. So the three 100-gallon gas water heaters are on the left again, and then the solar thermal tank is on the right. Water coming into the system comes in at about 55 degrees. So just a little explanation of this is, so solar preheats the water. Water is circulated from the solar tank to water heaters, then throughout the building and back to the water heaters. Have seen the temp of the hot water coming back after circulating through the building and near the same temp as going out. There have been times when the solar tank temp is not hot enough that the water heaters are being used as storage tanks, not heating the water. So basically what I'm getting at is that this is very efficient, right? Those tanks on the left, they're just holding the hot water, not necessarily producing it as much as they would need to in a regular sort of setup. I am going quite quickly through this presentation, maybe because I'm nervous, but I might have more awkward pauses here to slow it down. So this is a funny slide. We've got a toilet here, but it's very important. So this is a low flow fixture, including other low flow fixtures that we have employed on this project. So that includes the kitchen faucet, the bathroom faucet, and the shower heads. So just the toilets save an estimated 509,000 gallons of water annually. We are actually still trying to find a dual flush toilet that meets ADA requirements. Typically the buttons at the top, right, aren't within ADA reach or grab requirements on a typical toilet, right? You've got your lever on the side. Pertaining to the kitchen faucets, so most kitchen faucets don't meet the 1.5 gallons per minute right here that we're showing. And all of the kitchen faucets, their aerators had to be changed out. Some more information, I would say what's nice is there is a common laundry, right, which also saves on energy as well. And they're located at the ends of the buildings. Only the 3-bedroom units have washer and dryer hookups. And then outside the building, the irrigation system is all drip. There's nothing being sprayed. It's very efficient. The landscaping itself is drought resistant and native to Central Oregon, which we are in a desert. So this is the last slide. Too fast. I'm going to say this is my favorite slide. I know Rob is on the call, but this is a quote from him. It's all about the quality of life for residents. People who have stable housing have a much better life. A building like this goes a long way to fulfilling that goal. That's a great quote. And for LRS, if we can make an affordable housing project sustainable, we should be able to make all housing projects sustainable. So when I practiced this presentation, it was 35 to 40 minutes. However, we blew through it.
Well, thank you so much, Matt. I am going to hand this over to Matt Bokar. I see we did get a few questions, so maybe you can walk us through those. And folks, please do continue to add your questions, and Matt Bokar will jump into those as well.
Thanks, Ellen, and thanks, Matt D. That was fabulous. We appreciate you jumping in. I know you're subbing in for team members who couldn't make it today, so thank you. First question from John B. Has there been any problem with wind-blown snow coming in through the large attic ventilation louvers? And I imagine there's probably a larger conversation around the roof in general. So, Matt, does that sound like something you can address?
Sorry, do you hear me okay?
Yeah, so I'll defer to Rob, right? Because he's on the call here. Thank you so much, Rob, for being here. So
no problem.
How about it?
Yeah, I was brought in at the last minute, so you'll have to forgive me. I haven't actually seen the presentation in full length until now. But I will say, just with regard to snow issues in the large gable end vents, no. Where we have snow issues is in the, how do I best put it? There are walk-up areas. There are no elevators in this particular project, and so those particular, I don't know how best to refer to them, but it's just you walk up exterior stairwells, and yes, there we have a problem, and it hasn't been resolved yet. How to handle that?
In the breezeways.
Yeah, thank you. That's a good choice. Yes, breezeways. Yeah.
Matt, you spoke to unit mix and the variety of public funding sources went into this one. The question is the unit mix overall for the project. Could you speak a little bit to that and how you arrived at that unit mix?
Oof. I'm not sure I can give you that information. I'm too far removed from the project at this point. Yeah, I better hold off on that.
I will hold off on that as well, but I know Jim will have it at his fingertips, so we can answer that.
Fabulous, thank you. Question came in about the heat source provides the supplemental heat for the water heaters if the solar does not do it all. Could you talk a little bit more about that, get into a little bit more granularity?
Yeah, it's Rob again. I'll say we have experimented with a couple of different ways to do solar thermal. And the earlier ones, unfortunately, had a lot of moving parts and frankly did not perform all that well. So on a project that we call Azimuth 315, we decided to try something different, which is known as a drain back system. And the drain back system basically doesn't have any heat exchange as the previous, I'll say the previous models did. The heat exchange there is really, they only use water. So it's not like there's a coolant or anything. And what happens is towards the end of the day, anything that's still in the system will drain back to those 1,000 gallon tanks. And then as needed, those tanks will release. It's a little bit hard to explain, but depending upon where the boilers are at, they're either going to release or hold back the water that's been held overnight. So you can see here, on the left-hand side, at least as I look at the picture, there are 3 boilers. I'm pretty sure they're done. I'm pretty sure we did these in parallel, as I recall, although it doesn't look like it here. But yes, I think by code, what happens is code really doesn't consider the solar thermal as being premier or the the first thing that we go to. And so really what you have to do is design the three boilers have to make sure that we have the capacity to heat and cool, or I should say to heat the hot water without the solar thermal backup. So that's why sometimes it's a little bit hard to actually gauge what the percentage will be in terms of how much of the overall hot water we can actually heat. And but over the years, it seems like a pretty good figure to use when they're working well is around 70% of the requirements of the building. And you're always going to have movement back and forth between the actual boilers and I'll just say in this case the 1,000-gallon tank, holding tank.
And to clarify, the question was about the heat source that's supplementing the solar, and it's gas water heating for those.
Say that again, ML. Just yeah.
The question was,
Yeah.
what heat source provides the supplemental heat for the water heaters if the solar does not do it all?
Right.
And at Canal Commons, it's natural gas water heaters.
Yes. Okay. Thank you. Yeah.
ML, thank you. That was super helpful. Could you expand on that for just a second? Did the team consider going all electric, or did gas just pencil better?
I can't answer any of the pencil questions. I can say though that what's fascinating and admirable about what this project has is solar is the most energy efficient thing you can do for water heating because it's so direct. However, we don't have incentives for that, and Roy mentioned that about they weren't doing it for the reasons that a lot of us make some decisions. It's not just for the energy efficiency in terms of what you're going to get on your utility bill. They're looking at it in a very comprehensive manner. When the sun is shining, it's heating the solar water panels on the roof, and that's going to preheat the water before it's going through the gas water heaters. And it's highly interactive. I think it was basically what Rob was trying to convey.
Yes.
Whatever's happening with the sun shining, what's happening on the roof with the solar hot water panels, what the demand is on the hot water tanks. It's all working in a very interactive way and responsive.
ML, I could just add to that. If you're looking at that picture, I don't know if you have it up on your screen, but if you look at the far end, where we have the wall with clearly there's like a bronze fixture there, which we call the mixing valve. And that is key to the whole system because the mixing valve, let's just say, for instance, well, generally speaking, if we're storing hot water, I make sure I get this right. I believe that it should be stored at 125 plus. Otherwise, we've got Legionnaire issues. And so then when we actually get to the mixing valve, we don't want to deliver it at 125 or 130. We probably want to deliver it at 122. And so the mixing valve, because it's set properly, will actually add cold water to it so that when it goes out, and it goes out to all the units, it's now down to 122. And those numbers are somewhat flexible, I'll say, depending upon what we have going on. But I think, clearly with a great mixing valve, you can do an incredible amount of things with solar thermal. And I think the other thing that most people don't understand, but I'll say the tenants love it. So this hot water, when it gets circulated to all three floors, so when somebody then turns on their heater or turns on for hot water on the third floor, they're going to get it within 5 seconds. They don't have to wait 25 seconds or 30 seconds for the hot water to get there. It's always circulating with one circulating pump and can keep it going. So I hope that gives you some insight. It's just, we think solar thermal is fabulous, frankly.
Thank you, Rob, ML, Matt, D. That was terrific. The next question, and Matt, it was probably good you hustled through because there's a lot of questions in the chat, so we have plenty of time
on purpose, for sure. Definitely.
Totally deliberate, intentional. Question for the team has to do with parking. So is there any covered parking? And then if there is covered parking, is there any related solar PV?
This one we decided to not go with solar. Solar on the parking area. And it was sort of driven a little bit of just limited access to the sun. when you look at the distance between the two buildings, especially on the phase one, once you start putting in, and you have 3 stories, and then on top of that, you have I can't remember exactly what the height was on those pitches, but I think probably the end adds enough, probably another 20 feet in height, a little bit less than that. And so, a lot of times during the day, we were losing solar access. So we just decided on that particular project that it wasn't worth it. I think it's something that we do on a project by project basis. So for those that are familiar with, say, ASMA 315, well, yes, we have some very large solar systems that are directly over a significant number of carports.
Thanks, Rob. That was terrific. One other parking question related to EV. Is there any EV parking? And could you talk a little bit about how that works?
Yeah, so I say with this particular project, we put in all the necessary requirements for us to actually. I'm trying to remember what it was, but I think we have a total of 4 pedestals, and each pedestal will handle 2 chargers, as I recall. And all of that now is underground. And when we get to the point where we think it makes sense to bring it on, then we'll bring it on at a very low cost to us.
Moving away from parking, Sharon had a question about, was gray water or rainwater collection considered and potentially used in any way?
With this project, I'd say considered, but no. We have 3 other projects in total where we actively harvest rainwater. And we think it's great, especially if the rainwater can be used sort of in close proximity to the building. It's a little bit problematic depending upon the plants that you actually choose, because you want to make sure that they are somewhat drought tolerant. That's why on most of our properties we use lavender, and that's clearly there's a reason for that. It's just that the lavender is very very drought tolerant. So if we don't get enough water off the roof, we can clearly turn on the irrigation system, but we don't like to do that. So with lavender, you have more flexibility for sure.
That was terrific. Thank you. Next question has to do with kitchen aerators. Can you please clarify why kitchen aerators were replaced? Was that about performance satisfaction, or did they not meet some requirement?
That's a good one. I can't speak to that. I have to say with this particular project, I didn't actually run. I should know the answer, but I don't there. I'm not exactly sure what went wrong.
Yeah, well, and I want to clarify, I don't believe that I want to make a distinction between a plumbing fixture and the aerator. And some plumbing fixtures, you can actually just add I've been told it only costs $5.
Yeah.
to
Exactly.
reduce the flow rate. And on the Energy Trust side, we go through and do an actual site verification for the low flow plumbing fixtures. And toilets, it's lovely to save water, but they don't save energy. And Energy Trust of Oregon, we focus on energy. Mm-hmm. So we look at the flow rate. We actually field verify after the building it's been installed and construction is nearing completion. We field verify the flow rate on the bathroom aerators and the kitchen aerators, or the bathroom faucet and the kitchen faucet. It's kind of cool. I love the sort of science behind it. It's so simple. You can get one for yourself. It's a plastic bag that's calibrated so that when you count 5 seconds with the water turned on hot and cold on full, you put the bag under that flowing water, count 5 seconds, and then turn the water off, and you can see the flow rate for the actual flow rate, not the rated on the spec sheets, but the actual flow rate of that fixture. And that's what we field verify for the Energy Trust incentives for multifamily projects.
Yeah, thanks.
Yeah, I agree with that. And that's what Jim had told me. It's like, okay. This thing, the faucet might say 1.5, but is it actually?
Okay.
Thank you all. That was super helpful. Matt D, you mentioned the number of exterior wall systems that were considered before you landed on the staggered stud. Question from Kevin W is, was there any specific reason why SIPs were not considered for the structural envelope?
I'd say probably the only reason is that we haven't used them before. I mean, we're very familiar with insulated concrete blocks. You know, I'll just say I've experimented over the years with staggered walls, and but I've never used a SIP personally.
Thanks, Rob. Super helpful. Thank you, James A, for posting this question. Ubiquitous. Was there a cost comparison done between the VRF system versus individual mini splits for each unit?
And I'm sorry, what's the question with regard to that then?
Was there any kind of cost comparison done between the VRFs versus mini splits?
Well, if I understand it, I mean, the VRF is somewhat integral to mini splits. They sort of make the same, they're all coming in to make the package, and the package deal is the variable refrigerant flow capability of the system. So I would say no. But clearly we bring all of those elements to play, where sometimes you can say, yeah, let's not put in an ERV. That's an option. We believe the ERVs work incredibly well. They're not that expensive. And in addition to that, when you get to a point where you want to start, I'll just say scrubbing wildfire smoke so that you can recirculate it through the building, then the ERV system is integral to that also, and it can be put in as an add-on. I'm not sure if I answered the question or not, but I just say, you know, when it comes to the variable refrigerant flow, it's incredible how well it works. I mean, the simplicity of it is, yes, and I think, Matthew, you used the example. There, you can have a day, especially a shoulder, what we would call a shoulder weather day in Central Oregon. And so the south side of the building may well be calling for cooling, you know, and on the back side of the building, maybe we'll all be calling for heat. So south and north. And that all happens, I'll say, somewhat automatically. I mean, because we're moving BTUs around in the via some sort of what's the best word? Substance, you know. So I don't know what the actual liquid is anymore, because it's changed over the years, but I'll say whatever that substance is, we can move it around easily, and it's all done automatically. And I think it's great. And then when you add the ERV possibilities in, just in terms of especially problems with smoke and other related things, they work very well.
I think also, you know, beyond the sustainability of ERV, the end user experience of this system, especially in Central Oregon and in the summer, unfortunately with some smoke, versus a PTAC or PTHP.
Right.
If you want to cool your unit, you only have one option for a PTAC, and that is to blow air straight from the outside right through a filter that doesn't really filter, right? So this is fantastic, right?
Yeah. And I think, you know, clearly to get full benefit, there needs to be some education with the tenants in a multifamily building, because as we'll say to them, look, you know, if everybody leaves their window open and we're going to run the ERV, there's no benefit. And okay, so we might tolerate 1 or 2 tenants doing that, you know, but if we have 10 or 15 doing it, then it's a waste. And so generally speaking, we try and make sure that at lease up and other times, you know, that we educate them a little bit to say, hey, you know, I mean, we're asking for your cooperation. The last thing we want to see is when we drive in and park on the south side of the building, it's 90 degrees outside and you have all the windows open. That makes no sense at all. You know, it makes no sense, because you're just killing it for everybody. So there is a bit of an education process there that goes on.
Similar line of questioning, Rob. Do the units have air conditioning, and what kind of controls are built in for residents to manage their heating and cooling?
Residents can manage it, both heating and cooling. The only thing that we do on occasion is if we have somebody who has a medical issue and has the proper documentation, let's say they're asking for heat at 80 degrees, you know, that we may well have most of the systems set at 76, then we would have to make a change and allow that particular unit to allow themselves to actually bring the temperature in the unit up to 80 degrees, and vice versa, you know, with colder temperatures.
I remember the buildings were completed last year, 2023. I don't know exactly how long they've been operating, but the question is, have you found any delta versus the actual HVAC performance and the operational cost versus what was modeled during the design phases?
And are we talking about sort of all of the so-called EEMs, or just in general?
I think we would be interested in any kind of feedback loop data, you know, lived experience now that the buildings have been occupied. Do you have any kind of utility bill information?
Yes.
I'm going to have to interrupt and just make a quick plug for the Net Zero Fellowship research
Yes.
that Rob Roy has underway, and digging deep into exactly that question, is looking at their portfolio of projects and how well they're performing.
Yeah, so we, just to give you a little bit of coverage there, I mean, really what we're doing is we're looking at the performance of 3 of our properties, and digging deeply into it, and then comparing it against what we had projected, because we put a, I don't know how best to call it, you know, it was a computer tool where we could actually look at everything we were doing from a financial standpoint, and then make some statements as to which one should we not do, which one should we do, how long is the payback. So just a case in point, just broad scale. I mean, if we would get to a point where we'd say, okay, look, you know, we're prepared to spend $500,000 over and above what's normally would be, we would be paying for all of these sustainably related issues. And that would be, that 500,000 would be after any initiatives, any financial initiatives that we might have. Well, you know, and then we look at a 30-year cash flow of the benefits and the detriments, and basically look at that 30-year cash flow and bring it back to what it's actually worth today. And over again, the numbers were something like this: we're going to spend $500,000 today, and if we actually look at the net present value of the cash flow for the next 30 years, that value of that investment is worth $1.5 million today. And once our equity partners and our debt partners started to see that and started to realize that there's some huge benefits there, and when you think of it. But the problem is with a lot of builders, unfortunately, they'll build and maybe run it for 4 or 5 years and sell it. But where the real benefit comes in is when you hang on to it for, say, 30 years. And so that's the way we build. I mean, as a rule of thumb, we always say, look, we want this, we need this thing to be super up until at least age 60, because a lot of our debts go out to year 60. And so we need to set the financial arena up that way. And so clearly when we look at it from a financial standpoint, and we use, you know, that sort of analysis, it's somewhat rewarding, yes, to look back and say, we were right. Unfortunately, we weren't right. We were a little bit wrong. And that little bit wrong was because a lot of the so-called EEMs, energy efficiency measures, I'll just say, let's just take a simple one. Maybe it's the lights outside. And so what we found is that a lot of those EEMs were overvaluated in terms of how much how much electricity they were actually going to either save us or help us make it. And so that's what we're working on now, you know, to just see.
I'm going to interrupt.
Yeah, go for
it. One, I don't want you to.
What's that?
I don't want you to present the presentation before we're ready. So,
okay, I won't say any more then. I'll just say that's what we're working on, and hopefully we can find a solution.
And I know that this program ends at the top of the hour, and I always like to respect that. And just to clarify, the research that Rob Roy and his team are doing is through our Net Zero Fellowship and Energy Trust of Oregon New Buildings Program. We support that research, and be sure that you are looking for that, because he will be presenting it later in this year. I'm going to hand it back probably to Ellen, right? Or Matt. I'm not sure how you like to wrap up.
Yeah. But yeah, thanks for bringing that to my attention, ML. I get too excited about it.
Hey, Matt, do you want to bring us home? Matt Boker?
Go for it, Ellen.
Okay, well, thank you so much, everyone. We really appreciate all of your attention and participation today. The great questions. Thank you so much, Rob and Matthew, for joining us. Matthew, the presentation was wonderful, and Rob, we really appreciated your input for the Q&A. Any questions that did not get answered, we will ensure that we cover those later. So please stay tuned to see responses in your inbox in the next few days. And once again, thank you so much, everyone. So happy you could join us today.
Ellen, can I just burst in and remind people
Yes, absolutely, Kathy.
that I am not automatically sending out certificates. So you have to email me and ask for your certificate. If you're an AIA member, your number will be automatically logged with National. But if you want a certificate, you have to email me.
Wonderful. Thank you again. And thank you, Matt Bokar, for facilitating the Q&A. And everyone stay warm out there. I think we're getting hit all over the state with some crazy weather next few days. So stay safe, stay warm, and thanks again for joining us.
Thank you
Good
all.
night.
Thanks, everyone.
Thank you all.
Bye, everybody.